Another quality attribute is testability. So software testability refers to the ease with which software can be made to demonstrate its fault through testing. Specifically, testability refers to the probability, assuming that the software has at least one fault that it will fail on its next test execution. So let's switch to the general scenario. The general scenario for testability can be the next one. What can be the source? The source can be either unit testers, integration testers, system tester, acceptance tester, end user, either running test, and so on. The stimulus, it can be a set of tests is executed due to the compilation of a coding increment such as a class layer or service, the completed integration of a subsystem, the completed implementation of the whole system, or the delivery of the system to the customer. The artifacts usually it will be the unit of code. It can be a subsystem or the whole system in the artifact being tested environment. The test can happen at development time, at compile time, at deployment time. The response. The system can be controlled to perform a desired test, and the result from the test can be observed. And how can we measure it? The response measures are aimed at representing how easily a system under test gives up its fault. So measures might include the efforts involved in finding a fault or particular class of fault. Based on this general scenario, let's take a look how the concrete scenario for testing can look like. The input is the next. The unit tester completes a code unit during development and performs a test sequence whose results are captured and test given 85% pass coverage within 3 hours of testing. Let's try to build it. Based on this input and general scenario, the concrete scenario will be next. The source will be unit tester. What is the stimulus? The unit tester completes the code unit. Yes, completes the code unit. So code unit completed. Artifact is code unit on the development environment, and the response is result captured. How can we measure this result? That 85% pass coverage in 3 hours. Tactics. Now, how can we achieve it? Generally, we can divide for 2 categories of tactics for testability. It's adding controllability and observability to the system, and another one is limiting complexity in the system design. For control observability, here is such tactics as specializing interfaces. So when you will have some specializing interfaces, it will allows you to control or capture variable values for a component either through a test hardness or through normal execution. The examples, it can be for a set and get methods for important variables, modes, and so forth. Record and playback. The state that caused the fault is often difficult to recreate. The QA engineers, they know it. So recording the state when it crosses an interface allows that state to be used, and you will be able to recover it. So this is one of the tactics that you can plan into your system, which, believe me, can really helps. How can you record it? The simplest way is to just put the logs. It's not just only one way, but one of the simplest. Another one is localized state storage. So systems to start a system, subsystem, or module in an arbitrary state or for the test, it is most convenient if that state is stored in a single place. So if the state is distributed, it becomes difficult, if maybe sometimes even not impossible. So this is about the choice of granularity, and it depends on how the state will be used in testing. So during the design, try to make the put attention for granularity of your models in the perspective of easy to testability for it. Abstract data source. If you will look, this is about controlling the state. So easily controlling the input data will make it easier to test it. For example, if you have a database of customer transaction, you could design your architecture so that it is easy to point your test system at other test database, or possibility even to files of test data instead. So if you will have nice level of abstraction and you can switch some components without changing the API for which you are communicating, it will make your test opportunities better. The sandbox. Sandboxing refers to isolating an instance of the system from the real world to enable experimentation that is unconstrained. So this is generally you are trying to separate to a virtual resources or different environment. Executable assertion. This is generally another one approach, I would say, which is correlated with the previous one. The assertion are often designed to check that data values satisfy specific constraints. So assertion are defined in terms of specific data declaration, and they must be placed where the data values are referenced or modified. It means that you can use some precondition, some post-condition for each method on a class level, for example. This is about it. Limit complexity. Limit complexity, we can divide for two general things. It is limit structural complexity and limit non-determinism. I will try to explain it with the difference between what is the difference between both of them. So the second one is limiting behavioral complexity. So it means in the first way, you can limit the structural complexity, and the second one, you can limit behavioral complexity. And when it comes to testing, the behavior is very specific for how it's, let's say that non-deterministic systems are harder to test than deterministic systems. So this tactic involves finding all the resources of non-deterministic, such as parallelism or maybe weeding them out as much as possible. I guess I will need additional examples and explanations here. Let's plan it. So one of them, just one quick example is that, for example, multi-threading system, they can respond to unpredictable events. But for such systems, you can use other tactics. For example, record or playback. So you can, instead of use use the statics, you can think about how can you notice that the behavior will be different. I think it's enough for testability, and let's take a look for usability.